It has been a week since I last recorded. The camera died in the middle of doing this next problem, and so many things had gone wrong that day that I just quit. I started recording today, and then this light died, and then I plugged it in and it started flickering. Is the light flashing? So I think this video is cursed. TBD, we'll see if I'm able to actually record the next problem. If this is on the internet, it means I managed to get it together. Okay, so we're gonna look at 2021. Why don't you pause the video so you can read the question. Okay, part A, compare the distributions of average attendance between the old and new stadiums. So comparing distributions, usually when we're comparing box plots, we use like VSCO, like variability, shape, variability, shape, center, and outliers. So once again, I'm not gonna write anything down, we're just gonna talk. Variability, it seems like the new stadium, there's a little bit more variability, especially like the quartile 1 is a little bit bigger. And just generally the range seems like it's a little bit bigger. You can't really tell from the box plot if it's like, you know, normal, skewed, but maybe the new stadium is slightly skewed to the left. Centers, the new stadium has a much higher center than the old stadium, and then outliers, there don't appear to be any outliers. Make sure anytime you're comparing that you use comparative language in your answer, like more than, less than, the same, different, things like that. Okay, for B, the following scatter plot shows average attendance versus year. Okay. Oh, and we have old stadium and new stadium with two different icons. Interesting. It says to compare the trends in average attendance over time between the old and new stadiums. Okay, so usually when we're describing a scatter plot, we don't use VSCO, but we do talk about form, strength, shape, and outliers. So I would say the form, for the new stadium, certainly linear, certainly positive and strong. There is a strong, positive, linear relationship for the new stadium. For the old stadium, it's somewhat linear, somewhat positive, fairly strong. I mean, there is a pattern there, but once again, it says to compare, so we should be using comparative language. So I would say something like it's not as strong or linear or positive as the new stadium. In part C, we're supposed to consider the following scatter plots. With graph 1, we have the number of games won compared to average attendance. And then in graph 2, it's the same information, but it's split up with the old and the new stadium. Graph 1 shows the average attendance versus number of games won for each year. Describe the relationship between the variables. This is getting very repetitive. Strong, linear, positive relationship. And then just to include some context, I'd probably say something like the more games they won, the higher the attendance. Part 2, it says graph 2 shows the same information as graph 1, but also indicates the old and new stadiums. Does graph 2 suggest that the rate at which attendance changes as number of games won increases is... Does graph 2 suggest that the rate at which attendance changes as number of games won increases is different? Oh, wow. Does graph 2 suggest that the rate at which attendance changes? Is it different than the new stadium compared to... I can't read. I can't read. Okay, so it's basically asking if the rate at which attendance changes as the number of games won is increasing, is that different in the new stadium versus the old stadium? No. I see the same trend. In the old stadium and in the new stadium, the more games they won, the more people attended. Seems the same to me. All right, let's see if part D is even a little bit different. Consider the three variables: number of games won, year, and stadium. Based on the graphs, explain how one of those variables could be a confounding variable in the relationship between average attendance and the other variables. So a confounding variable is one that is affecting both the explanatory and the response. It's like mixed in to your two variables that you're trying to examine. So explain how one of these could be a confounding variable. Now, the explanatory and response that they're talking about here is average attendance. This video's cursed. It's so cursed. I can't... Is it just gonna be dark? I don't care anymore. It's just gonna be dark for the end of the video. Okay, so one of these variables has to be messing with the average attendance, basically. So maybe we could focus on the stadium. Because like the original thing we saw was that the new stadium had higher attendance than the old stadium. But then graph number 1 kind of showed us that the more games they won, the more people attended the games. So like graph 1 makes it seem like the more they win, the more people show up. But then when you look at graph 2, were they showing up because people are winning more games, or were they showing up because the stadium was new and it was like really fun and exciting to go to a new stadium? I think that's it. I think the new stadium is the confounding variable, because we can't tell if more people are coming to the games because the team is winning more, or if they're coming to the games because they want to go to the new stadium because it's like fancy and nice and new. So I think that's what I would explain, and I would include a lot of context and specifically try to mention how we can't tell if the response is changing because of games won or stadium. And my dudes, that is it. That is the end of question 6. If my light had held on for just 2 more minutes, Okay, this has been question 6. I'm ready to be done. It'll go a lot better for you than it did for me. I took all the bad luck from you, so now you'll be fine. There's more AP review content to come, so hit that subscribe button and click the notification bell so you don't miss any uploads. And then leave a comment if there's something specific that you want me to cover in a future AP review video. Okay. Bye.